Hello and welcome. This is going to be our lecture video for March 8th through 9th. Let's go get our notes out. Quick warm-up is, what is the domain of the following? So typically, the domain is going to be all real numbers except for any excluded values. Now we saw a few exceptions for that with functions like square roots and logarithmic functions, which we could just express with an inequality because they didn't reach all the way into the negatives of our graphs. But rational functions typically do. They go all the way to the left, all the way to the right on our graph. So we can just say domain is x equals all real numbers, comma, except x cannot equal any excluded value. Now to figure out those excluded values, we look at the bottoms of the fractions, because pretty much the only thing that we're not allowed to do is divide by 0 when we have a rational function. So we have to just ask ourselves what value causes us to divide by 0. In this top example, it would be the number 2. 2 minus 2 is 0. Here, it takes just one more step. We have to factor the bottom. We'll factor into x plus 5 and x minus 5. The values that make these equal to 0 are negative 5 and 5. So we can just say x equals all real numbers, except x cannot equal plus or minus 5. Both of those values will cause us to divide by 0. All right, and that's all we need to do for these. We just almost always start with x equals all real numbers and then exclude our excluded values. All right, goal for today is to use rational equations to solve for a missing variable in physics problems. Why are we doing this? So we can find the unknown in work, travel, mixture, and electrical engineering problems. Okay, got a bunch of word problems coming at you. Starting with this one. A carpenter can build a desk in 6 hours. Another carpenter can build a desk in 8 hours. How long will it take the carpenters working together to build one desk? And we're imagining that they don't slow each other down at all. You know, they maybe just build from two ends and meet somewhere in the middle, but it wouldn't be the exact middle because the first carpenter can build faster than the second. So here's how we set this up. We've got to define a variable x for time. These units are given in hours, so we'll say x equals hours. And the first part of our expression will say x over 6. This is the amount of a desk the first carpenter can build in x hours. After 6 hours, he would have built 6 over 6 or 1 desk. After 12 hours, 12 over 6 would be 2 desks, and so on. Second part of this, we want to add it to an expression for the second carpenter. Build this part just the exact same way, but with an 8 on the bottom for the amount of a desk carpenter B can build, and together they're going to build one desk. Now that our equation is set up, we're going to solve it by getting a common denominator. Whatever we do to the bottom, we do to the top. We get 8x over 48 plus 6x over 48 equals 1. Now that we've got a common denominator, we can combine these fractions. 8x plus 6x is 14x over 48 equals 1. Now that we've got this down to a single fraction, we can multiply by the bottom of that fraction to clear that fraction. Get this down to just a nice linear equation. 14x equals 48. Divide both sides by 14. And we get x equals 48 over 14, or 3.42 hours. Now, a trick here is take that 0.42, just the 0.42, not the 3, and multiply it by 60. And we will get that this is 3 hours and 25.71 minutes. And you can repeat the process and take just the 0.71, multiply by 60 to get minutes and seconds, if we want to be that precise. But I think we're okay to just leave it like that. All right. Now onto another work problem. This one's got a slight twist. So Bob can paint a fence in 5 hours, and working with Jen, the two of them painted a fence in 2 hours. How long would it have taken Jen to paint the fence alone? So this kind of feels like it's going to be a system. We can actually do it with just a single equation. We'll set up our equation pretty much the same way. First, x equals, well, we don't need x to be hours because we actually have the hours. What we need is J to equal Jen's rate. All right, and so now Bob can paint a fence in 5 hours. They then worked for 2 hours, so we know that Bob painted 2/5 of that fence. If he had been given 5 hours, he would have gotten to 5/5 of that fence, but he only had 2 hours, so he painted 2/5 of that fence. All right, so we know Jen had 2 hours working at her rate to paint her 3/5, so we can say 2 over her rate should equal 3/5, and together this should equal 1 fence. So the general form here is time on top, the different rates on the bottom always equals our total amount of product, which is often just 1. We're trying to just like build 1 desk or paint 1 fence, but watch out for if this number over here gets changed. We're trying to paint 2 fences or 3 fences. All right, now this can be solved by first subtracting 2/5 from both sides, and we get 2 over Jen's rate equals 3/5, which is how much of a fence we said she built. We can cross multiply this if we want. 2 times 5 is 10. J times 3 is 3J. And then divide both sides by 3. And we get 10 over 3, or 3.33 hours per fence. For Jen, or 3 hours, 20 minutes. All right. Tank problem. One pump can fill a tank with oil in 4 hours. Another pump can fill the same tank in 3 hours. How long would it take to fill the tank if both pumps worked together? So now this, we don't even have to pretend like the two workers won't get in each other's way, like with the fence and the desk. With pumps working to fill a tank, then this is very real world. This is exactly what would happen if we tried to use 2 pumps that work at different efficiencies on the same tank. So this would be a good one for me to embed a question and for you to try, and then I'll just quickly put up my work. All right, so x over 4 plus x over 3 equals 1 tank. All right, this becomes 3x over 12 plus 4x over 12 equals 1. Add them together, we get 7x over 12 equals 1. Multiply 12 to both sides. 7x equals 12, divide both sides by 7. X equals 12 over 7 is 1 hour. Take away that 1 hour, multiply by 60. And 42.85 minutes. Or 42 minutes, 51.4 seconds. However you want to put it, be ready to convert time units on a multiple choice quiz or test. All right, what do you think this diagram below represents? I'll embed another question here for you to take a guess. All right, if you guessed that this was a circuit diagram, you were correct. And these little zigzag lines are resistors, all right, that resist the flow of the current around the circuit to different degrees. All right, if you have multiple resistors wired in parallel, meaning that they're next to each other and the current can decide to flow through either of them, then the total resistance can be calculated with this equation here. 1 over the total resistance equals 1 over the resistance of the first resistor plus 1 over the resistance of the second resistor, and you can just keep adding 1 over R sub whatever for however many resistors you want to put in parallel. All right, but the more you put in parallel, the more it will lower the total resistance. So if you're really trying to fine tune it, you might, use multiple resistors in parallel to target a very specific total resistance. All right, so here's our circuit diagram with some labels. What would be the total resistance of this? Well, 1 over R sub T equals 1 over R1 plus 1 over R2. There's only 2 resistors here. So 1 over RT equals 1 over 20 plus 1 over 30. And now to solve this, we need to combine these. The least common multiple between 20 and 30 is 60. We don't have to multiply them by each other quite. We can just multiply by 2 and 3 because they both have a factor of 10 that we don't have to repeat. Whenever I do the bottom, I do the top. I get 1 over my total resistance equals 3 over 60 plus 2 over 60. 1 over my total resistance equals 5 over 60. Cross multiply, 60 equals 5R sub T, divide by 5, divide by 5, and we would get our total resistance is equal to 12 ohms. All right, so which is less than either of these, which makes sense because if we had, opening up more paths for the electricity to flow should lower the overall resistance because now, your electron can pick, does it want to go through this way or this way? All right. Find the speed of the wind. San Francisco to Chicago is 1,850 miles. An airplane can cruise at 480 miles per hour. That's airspeed. Ground speed would then be this number, either plus the wind speed or minus the wind speed, depending on if you're going with the wind or against the wind. The round trip takes 7 hours and 45 minutes. So this is an interesting set of 3 facts. But from this, we can figure out what the speed of the wind must have been. So we'll start with a very basic formula that distance equals rate times time. All right, and this should make sense. If I'm going 60 miles per hour for 3 hours, I end up traveling 180 miles. I just multiply those. All right, and now it's time to set up our equation here. So I'm going round trip, so I need to take that distance and double it. 1850 times 2 means I travel a total of 3,700 miles. All right, this is split into 2 individual sections, each that add up to 1,850. So I kind of want to do this differently because if I just try to add them together, it's hard. I'm going to kind of set it up a little bit like a system, but I'm still only going to be solving one equation. So okay, the first trip is 1850 miles. My rate is going to be my cruising speed, 480. We'll say this time it's with the wind, so it'll be plus W times my time, and we'll convert this into a decimal. 45 minutes would be 0.75 hours, so 7.75. But okay, I don't know. That only gets me halfway there. This is a tricky problem. Let me pause here and think about it for a second. Okay, I've thought about it a little bit more. I think I know how to solve this. So let's divide rate to both sides. And our distance equals rate times time. And we've got distance divided by rate equals time. All right, and now we can do our distance, 1850, divided by our rate, which is going to be 480 plus W, one direction. That equals part of the time, but we don't have to know that because we're going to add that immediately to the other part of our time, which is that return trip of 1,850 miles divided by the 480, which is our speed minus the speed of the wind. And together we know that that's 7.75 hours. All right, now we're going to attempt to solve this. Equation 4W. All right, got to get a common denominator. I have to actually multiply these by each other, even though it looks like they have something in common. They really don't. You do have to multiply them by the entire other expression. So to this first one, I multiply by 480 minus W. To this one, I multiply by 480 plus W. And whatever I do at the bottom, I must do at the top. So 480 minus W, 480 plus W on this side. All right, and so I'll go ahead and distribute the 1850 while doing this. Just keep the bottom factored. So 1850 times 480 is 888,000 minus 1850W plus 888,000 plus 1850W all over 480 plus W times 480 minus W equals 7.75. All right, now these two terms cancel and these can be combined. I've got it in my calculator, so I'll just multiply by 2. And I get 1776,000 equals, I can keep the bottom factored a little bit longer. I am going to have to distribute it eventually. 480 plus W times 480 minus W equals 7.75. I can multiply both of these terms over to the other side. I'll just draw an arrow to show that I'm multiplying them to the other side. And now I've got 1776,000 equals 7.75 times 480 plus W times 480 minus W. And now I have a quadratic to solve. So I do need to distribute all of this side. These are conjugates, so they do eliminate their middle terms, which saves us a little bit of work. We get a W, or a negative W squared, and 480 times 480 is a 230,400. Distribute in our 7.75. 1776,000 equals negative 7.75 W squared plus that times 7.75 is 1,785,600. Now, it might look like I need quadratic formula, but I don't have any linear term here, so I can actually just move everything away from the W and solve by taking square roots. So subtract away this massive number from this massive number, 8600, and 1776,000 minus second answer, I get actually a smaller number, negative 9,600 equals negative 7.75 W squared. Divide away that negative 7.75. And I get 1,238.7 equals W squared. I'll keep that whole number in my calculator as I take the square root of both sides. To get that, my wind speed must have equaled second square root of second answer, 35.19 miles per hour. All right, so that's that whole problem. The numbers got pretty big in there. The basis was distance equals rate times time, but you had to do two expressions for the two different times, and then just show that we know that their sum is 7.75. All right, on to mixture problems. In order to make IV bags at the hospital, you have a stock solution containing 10% strength medicine and a solution containing 30%. How much of the 30% must you add to 1 liter of the 10% to create a mixture that's 22% strength? So here's how we're going to solve this one. You start with what you have. I've got 1 liter of 10%. Well, 1 times 10% is 0.1 liters of pure drug divided by the 1 liter of volume. So this is the active ingredient divided by volume. And now we're going to add to both sides of this equation as we add in our stronger solution. So as I add in my 30% solution, I get 0.3x liters of active ingredient plus x liters of my 30% solution. So here I should have defined my variable x equals the volume added of 30% strength. All right. Now, what my result to be is active ingredient divided by volume to equal 0.22, my desired strength. And let's go ahead and solve this. So I'll multiply both sides by 1 plus x. That will cancel it on this side, and I get 0.1 plus 0.3x equals 0.22 times 1 plus x. You can distribute it in on this side. I maybe should have just done that right away. It's 0.1 plus 0.3x equals 0.22 plus 0.22x. Move my x term. 0.1 plus 0.08 x equals 0.22. Move my constants away from my variable. 0.08x equals 0.12, and divide away my coefficient. And that looks like that should be 1.2. X equals 1.5 liters. Double check. Yes, 1.5 liters. All right, so you add 1.5 liters to our 1 liter, and you will get 22% strength. All right, another mixture problem. So you've got 10 liters of juice, of a juice blend that's 60% juice. How many liters of pure juice need to be added to make a blend that is 75% juice? So we've watered down our orange juice a little bit, but now we're going to try to add back a little bit more pure orange juice to get to a mixture that's 75% juice. I think this would be a good one to pause and embed another question for you guys to try this one on your own. All right, so 10 liters at 60% means 6 liters, just multiply those, 10 times 0.6 of pure juice. over 10 liters. And I'm going to add to the top, but because it's pure juice, I can just add an X to the top and the bottom. It adds both to the volume and to the pure juice, and we're trying to target 0.75% strength. All right, I'll multiply a 10 plus X to both sides. And I will distribute in my 0.75 to get 6 plus X equals 7.5 plus 0.75X. Move my variables to one side, constants to the other. To get that 0.25X equals 1.5. Divide both sides by 0.25. And I get that X equals 6 liters. So I will now have a total of 16 liters. 12 of those liters will be pure juice, and 12 over 16 does equal my 75% strength. All right. I believe this is our last question. Tamara bought 50 pounds of fruit consisting of Florida oranges and Texas grapefruit. She paid twice as much per pound for the grapefruit as she did for the oranges. If Tamara bought $12 worth of oranges and $16 worth of grapefruit, then how many pounds of each did she buy? All right, so we'll say X equals oranges. Well, let's be very specific here, is pounds of oranges. Y equals pounds of grapefruit. Now I would use O and G, but O looks too much like a 0, so I'm just going to go with X and Y. And I know one thing is that for 50 pounds, that's just X plus Y equals 50. Now I got to figure out this next piece. So she bought $12 worth of oranges. So if we take the pounds of oranges, X, multiply it by their price, I think I might have to introduce a new variable. We'll say Z is the dollars per pound of grapefruit. So X times their price, which is, we said, twice as much for the grapefruit as she paid for the oranges. So I don't want to have to introduce a new variable, so I'm just trying to do everything in dollars per grapefruit. The oranges were twice as expensive, so it's only, if I have X is oranges, no wait, twice as much for the grapefruit. So this is, they were 1/2 Z for their price, half the price of the grapefruit times my oranges equals $12. And then Y times Z equals $16. Now I've got 3 equations, 3 variables. Let's go ahead and try and solve this. I want to isolate. I could isolate X and Y and plug them into this equation. I'll do that. So for this equation here, I've got, let me write it like X times Z over 2 equals 12. We'll multiply by the reciprocal here, which is 2 over Z. I'm going to put it across my Z, times 2 over Z. That X equals 24 over Z. And then for Y, I'll just divide both sides by Z. get that y equals 16 over z. All right, now I'm going to plug those both into the equation. X plus y equals 50. (24 over z plus 16 over z equals 50. Common denominator can add the tops. I get 40 over z equals 50. Do a little rearrangement on this. Bring the z over, bring the 50 under. So 40 over 50 equals z, or 0.8 equals z. So I know the grapefruit were 80 cents per pound. All right, she bought $16 worth of grapefruit. So I can take my $16 divided by 0.8 dollars per pound of grapefruit and get the pounds of grapefruit. So 16 divided by 0.8 is 20 pounds of grapefruit. And then if the total was 50 pounds, we can then figure that we got 30 pounds of oranges. And let's just make sure that that makes sense. We said oranges were half the price of grapefruit, so they should be only 40 cents per pound. So 30 times 0.4 gets me $12. Is that what I paid in oranges? $12 worth of oranges. Okay. So all that work, it was 20 pounds of grapefruit, 30 pounds of oranges. All right. Long video today. I'll just embed maybe 2 more questions. Call it good. All right. Have a great